Hi everyone. In this video, I'll demonstrate how to use Doenba to help write and edit the next two sections: assumptions and justifications, and data wrangling and feature identification. The primary goal in writing each section of a mathematical modeling paper is to convey to the reader our reasoning and the outcomes of every step we take, explaining why we make each choice and how well it succeeds. I first drafted 4 general assumptions, based on my understanding, to establish that the 4 provided datasets are appropriate for addressing the modeling tasks in the problem description. I then copied them into message Doenba and asked Doenba to add justifications for these assumptions. What Doenba returned looked good, except for the last assumption, where I wanted to assume that no sudden emergence of exceptional super talents would occur in any of the sports. I asked Doenba to revise its writing to include that justification. Doenba's revisions looked good, so I copied them into the writing area and made some minor edit. This is the preview of this section. Now let's work on the data wrangling and feature identification section. Normally, we would need to collect and clean data for the underlying tasks. However, because the data files were provided and we were instructed to use only those datasets, collecting additional data was unnecessary. I examined each file and confirmed that no data cleaning was needed. Given the earlier assumptions, I needed to extract from all data files the relevant information from 2000 onward and assemble a new primary data file to construct the prediction model. In this section, I first described the athlete event data file, for it provided the historical record for each athlete by name, the events they competed in, and their medal outcomes. I observed that in this dataset, each athlete has only binary medal outcomes recorded. 0 denotes no medal for each medal type, and there is no information on how close the athlete came to winning one. Although it is possible to predict medal counts for each event and country, the set of events has changed over time, making it difficult to forecast performance for newly introduced events that lack sufficient historical data for making reasonable predictions. Consequently, I decided to focus on predicting country-level medals under each medal type, using historical medal records, and excluded countries that have never won a medal, since including them would simply result in predicted zeros without additional information. During writing, I used refine and rephrase to improve my sentences. After explaining my rationale for creating a primary data file and selecting features for the prediction model, I executed Python programs generated by Doenba, see Part 1 data wrangling, to compute team size from the athlete event data file, determine cap from the program's data file, extract host information from the host data file, integrate these into the country-level medal counts file, and drop rows with year earlier than 2000, yielding a new CSV file. Upon examining this file, I observed a clear uplift in medal counts for host countries. Therefore, the primary dataset needed to be normalized to remove the host effect for more accurate medal count predictions. To do this, I copied the relevant suggestion from Doenba's answer, see Part 2, country-level medal counts, into the writing area, then revised and explained the normalization procedure. In particular, for each medal color, compute the host country's average medal count across non-host years. Derive the host uplift factor as the ratio of its host year medal count to that non-host year average. Remove the host advantage by multiplying the host year medal count by the reciprocal of the uplift factor. And finally, proportionally adjust the medal counts of all non-host countries so that the overall medal total equals the cap. Anticipating the need to typeset mathematical formulas with LaTeX snippets, I specified the common AMS math package through the reference panel. I wrote a LaTeX snippet that typesets the mathematical formula for a country's average medal count of a given type across non-host years. This is the preview of this LaTeX snippet. To add inline math symbols, click the equation button on the editing toolbar as shown, and type the symbols using LaTeX format without the math delimiters. I then used a Python program to normalize the primary data file, which had host effects removed for each host country, and captured a screenshot of the first page of the normalized CSV file. See the second video in this series. I clicked the image upload button to add the screenshot, entered the image caption, and submitted it for upload. This is the preview of this section. That wraps up this video. Thank you for watching. See you in the next one.